So, Samba is set up. However, you could stop here, but do you want to stop here? What if this hard drive is bad? It's like I said, the hard drive that I'm using is a used hard drive. So, what if we want to monitor this hard drive and be alerted if something's going wrong? Well, in that case, welcome to part 2, because I got a feeling now I'm going to split this in a couple parts here. And we are going to set up monitoring on this hard drive. Alright, so let me cancel this out, and let's get back in the putty. And here we are. So, to start monitoring with smart monitoring tools, we need to install them. They are not installed, so this is easy. Sudo apt-get install smartmontools. And we'll give this a bit to work here. Yes. Alright. Now that that is done, let's list block our devices, see what we got here. SDC1, of course, is my disk. Now, when I'm going to enable these tools, I'm not going to enable it for the partition or the mount point. I want to specify the disk. So instead of doing /dev/SDC1 or /media/SDC1, I want to do /dev/SDC. I want to reference the disk itself. So let's see if the device can be monitored to start with. So sudo smart control, or CTL, -I for our flag, and then our device, which is SDC. Now, as you can see, I'm getting an error here, which is unknown USB bridge. And I have a feeling that that has to do with the NAS expansion board. So what I'm going to do is I'm actually going to specify the adapter type in this command. And it's important that we recognize this, because we'll actually have to do this in every command that we use from here on. So I'm going to do the same command, smart control, except for I'm going to do -d SAT. There's a couple different adapters that you can specify. You can specify SCSI and different stuff, but SAT, I forget what it stands for, but it's pretty serial adapter, I think. It's pretty common, so even if this isn't specifically what you're doing, it's a good place to start. So -I, and then our disk, so dev SDC. And here we can see some information about my drive. So it's not in the Smart Control database, well, but it has smart capability, and smart support is enabled. That's the good thing. So now let's enable smart monitoring on this disk, just in case it wasn't. So sudo smart control, how do we do this? CTL, yeah, CTL, and then specify our interface again, and then -S on -O on -S on, I can explain these a little bit. I'll explain these a little bit later. And then dev SDC. Alright, so smart is enabled, and right now it's set to do automatic testing every 4 hours. That's perfectly fine. Now let's check the overall health of this device. So smart control, .ctl is what they use. And then -d SAT again, -h, and our device, SDC. Alright. Incomplete response, AT out registers missing smart overall health assessment test. ATA output registers missing. That's interesting. But the test result is passed. So we'll see. We'll get into a little bit more of this as we go. So we just checked the overall health. Let's run a test on this, because this is important to know too, in case you ever want to do this on your own. Like, you're setting up a NAS. So running a test now might be a good space, instead of, setting all this up just to get notified a day later that you have a bad hard drive. So let's run a short test. there's a way you can check the overall time of a test. I think it's sudo smart control specifier interface, and then we'll do t short dev sdc. Okay. Granted, that executes the test immediately as well, but it will tell you to wait about a minute to complete that test. So we'll give it a minute and then we'll check the results. If you wanted to do a long test where I put short after the T flag, you could have just put long. Those tests could take hours. It really just depends how long or how big of a hard drive you have, because it really does do a surface wide test there. Alright, so it's been about a minute. To check the results of this test, I'm going to go sudo smart control -d in our interface -l smart test, and then our disk. No, not smart test, it's self test. Self test, and then our disk SDC. Alright, so looks like we had some issues with this. And if you can see, this disk is really young, 23 hours, 263 hours. That actually explains a lot and why this drive is so bad. So I'm actually going to take this drive offline. I'm going to redo a lot of this with a new drive, chuck this one. If it's already failing smart test, you do not want it in your NAS. Even if it is a 1.5 terabyte drive, like, nope, not happening. So we're gonna chuck this drive, we're gonna put a new drive in here, get it all set up, and then we will speak again. So, hasta la vista, peoples. Alright, I am back, and apparently I have a guest. Meet Kitty 1. I'm not really sure if it's named yet. Hi, little kitty. Would you like to say hi? Anyways, I've replaced that faulty hard drive with a different one, and then as you can see up on the screen, I have the self-test up. Shows that all the self-tests have completed without error. It also shows that this drive has over 15,000 hours of service on it, which is a lot. Oh, its brother or sister is over there wondering why it's so high in the air and it's not happy. But when it claws the crap out of you, how do you get it down? Come on, little kitty, let go. Let go into the light. There you go, Mama Cat. So that is a lot of time on a hard drive. However, for my purpose, being that I actually don't know what I'm going to use this NAS for right now anyways, that is going to be completely fine. I will continue from here and do my review and testing and whatnot. So where we left off was checking the results of the self-test, which we ran ourselves. So now we need to configure those self-tests to be automatically ran and reported as well if something goes wrong. So to do this, what we are going to do is we are going to edit the SmartD service to use smart control to make these tests. So essentially what we're going to do is we are going to do sudo nano, which is our file editor, etc smartd config. And let me actually exit out of this. If you ever get a blank file and opening something up in Nano or a new file where it says at the bottom, that probably means that you had a misspelling. So go back, double check, and make sure you have everything right. If the file already exists, it will read it, it will show it to you. What we're going to do is we're going to look for the line that has the by scan that's not commented right here, and we are going to comment that out. That is kind of like the default scan every device that's connected command. It doesn't actually work with the way that this OrangePi is set up. So we're going to create our own. We're going to create it for a specific disk. If you have more than one disk, you can create a line for each disk. I'll try to explain what the options do as we go along here. So first we're going to start off with our disk. For me, dev SDC, we're going to do -A. The A flag is just some general options, quite a few of them actually, that you'll want to monitor. I won't explain that part in detail, but typically you're always going to want that on if you're doing smart monitoring through this. So then we'll do -D SAT, which is our interface, of course. -O on. -O, -S basically are the equivalent of their smart control. So dash capital S on. And then we're going to do a dash lowercase s, which is schedule. And we're going to do short test every morning at 2 in the morning. So boom, 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 02. And we're going to do our long test once a week, Saturday at 3 in the morning. So this will be L dash boom boom dash boom boom dash 6. It'll be the 6th day of the week, which is Saturday. And then 03. Whoop, oh shit. Damn keyboard shortcuts. I did something. Oh, okay. Okay. 03. Then not. See, I have numlock on. Now it help. 03. Boom. And then what we want to do is we want it to, if it fails for some reason, we want it to email us. So what we're going to do is lowercase -m, insert our email for me, lazypc@yahoo. And then we also want it to execute some scripts in case that happens. So capital M exec, and then we want it to do all the scripts that are going to be in user share smartmontools smartd-runner. Now let's actually also have this do a test as well. So we're going to do another -M here, and we're going to do, yes, stays on the same line, test. Okay. So let's save this, or write it by Control O, I believe. Yeah, Control O is write out, and Control X is exit. And then what we're going to do is we are also going to set Smart Monitor Tools to start automatically when the system starts up. So we're going to do sudo nano etc default Smart Mon tool or tools. That opens up this, and then where it has start smartmon equals yes, uncomment that line, and that's it. So write that out, exit that, and now we're going to restart the smart monitor and check if we got an email. So sudo etc initial.d smartmontools and restart. There we go. Just like it was supposed to happen. Now it should be actually trying to send me an email at the same time, and we're gonna see if we have that email in our email. So let's go check. And let me check my spam too. And what I can see is no email. Although Caitlin is trying to send me some mail order bride choices. I think I will ignore her for now. I'm happily engaged. Although she may move to Texas. So I don't know how happy that can be. So what we've done is we have got our OrangePi NAS up and running. We've gotten the hard drive partition and shared, and now we have our monitoring tools going. The final thing we need to do is get our monitoring tool to send us an email just in case something goes wrong. I got a hard drive with 15,000 hours on it. I might want that to happen. So the last thing to do is configure Linux to send emails. Normally this is already done and Linux can send emails on its own, However, in this case, not happening. We're gonna have to fix it. So, easiest way to get Linux to send emails is to use a package called postfix. The easiest way to install postfix is to install a package called mailutils. So sudo apt-get install mailutils. For postfix configuration, really the easiest thing to do is to just do an internet site. And then here we're going to put domain name. I have a domain. However, if you want, just put the domain of your email provider, Gmail, Yahoo, whatever. Really though, you should be putting a domain that you actually own. Here's the way it works. Alright, now that that is done, we're going to set our postfix server to only send emails from local applications on that server. That way, you know, just another step to help prevent our NAS from becoming some spam bot for the entire world to hate. So we're going to edit the postfix configuration file, sudo nano etc postfix, I put passfix, postfix main cf. Oh, that came up as a new file. Which probably means I did something wrong. etc post, oh yeah, I put an A in there. So exit that and postfix, not postfix. See, I gotta read. Now we're looking for a block, mailbox size limiter, recipient delimiter, and then inet interfaces. Okay, there's recipient delimiter, and there's inet interfaces, and basically we want to change it from all. You could do localhost. There's another one you could do as well. I think I forget what it is. I'm just gonna put localhost because I know that's correct, and write that out and exit. Now to send ourselves an email is pretty easy. Echo quotation marks. I'm just gonna put this as the body of the email. In quotation mark, then we want a pipe, and then we want mail, which is the actual mail command, -s for subject, and then in quotations, this is the subject line, unquote, and then the email that we're going to send it to, which, you know, for me, of course, I already mentioned it, lazypc@yahoo.com. Boom. Ooh. Oh, jeez. Me and my spelling today, man. I'm on one. Echo. There we go. Alright, now let's go check our email. And inbox. And I sent myself 2 emails. Although the second one's more correct. Oh, I see. So it did the second part of the command. It just didn't do the first part of the command for that body. That's funny. Okay, so now that that is working, we're going to send ourselves another email. We're going to send ourselves to... Oh, you can't see that. Oh, sorry. Inbox. Here we go. That's the email that I sent myself. So now that we know we got our first email, we're going to try to send ourselves another email. And that's going to be the test email from our smart monitor configuration. So sudo etc init.d psd, and then smartmontools restart. Go. All right, now that restarted, let's go check our email again. And come on, there we go. Root sent us. This message was generated by the smart D Daemon running on OrangePi with no DNS. The following warning error was logged by the smart D Daemon. Test email. for your device and what kind of hard drive it is. 640 gig, man, I don't get no 640 out of that. Anyways, so if you were to have a problem, we'll give you a little list of the problem here. Don't be surprised to find these messages as spam to start off, because you're kind of spoofing whatever domain you put there. So it's good to send yourself those test emails and then whitelist them. That way if you get a real one, it shows up in your inbox. Your system shouldn't be sending out a whole bunch of crap. Now, as a very last step, what we want to do is we actually want to go back and take off that test flag. That way we only get an email if something really happens. So sudo nano etc smartd.com. And let's go down here, go to our configuration line. There you get to the end of this. And we're going to take off this -m test. Write that out, save it, and we're good. We'll restart it one more time just to show that we're not going to get those emails again. So restart. Hi, kitty. Meow. I love you too. Restarted. Let's go check our email and inbox. Refresh. And nothing. So we are all good. We are all set. Our NAS is set up. Our hard drive and our share is set up. Our smart monitor is set up, and we'll get alerted if our hard drive starts going bad. That's more than some NASs do out of the box. Just gotta say that. So congratulations. Now here's the thing. Then I'll probably actually put this on my review as well, is that, you know, this NAS is okay, but it doesn't have the best performance. And I'll show you an example of that right now. Well, I don't need that. Network. I'm just using network discovery to connect to it. There's a couple other ways that you can use. However, network discovery for my purposes, perfectly fine. I have a pretty badass router. I typically don't have an issue with it, besides taking forever to initially find. OrangePi. I already have Assassin's Creed on here. Now, you can play stuff over the network pretty well. This Ethernet connection is what we want to pay attention to. Like if I go to seek, jumps up to 40, 1.2, 20. And so you can see that seeking is actually really not bad at all. So for individual use, sorry, I can't help it. I play it safe. Alright, so for individual streaming box use, probably not bad. If you had 2 or more clients pulling from this, it's going to degrade rather quickly. Your write speed, however, let me delete this off of here. Delete! And then we'll copy. Boom. Getting about 11 megabytes per second. And the reason we're getting 11 megabytes per second is because if you look over here at the Ethernet send, we are sending 98 megabits per second. And that's about what the OrangePi is capped at, because the thing is that, you know, you have your hard drive speed. Right now we're actually only writing to a 5400 RPM mechanical drive. But that's not the limiting factor. Those SATA controllers actually go through the USB bus on the OrangePi Zero. That's not the limiting factor. What the limiting factor is on this is that fast Ethernet connection, and it's called fast, but it's 10100, which means it maxes out at 100 megabits per second. And as you can see right now, I'm pretty well sending 90 something megabits per second all the time. Megabits, megabytes, different things. So that 100 megabits per second is equaling out to that 11 something megabytes per second. And so even if I try to play this while I'm doing this, like, my results are going to be piss poor right now. Like, I'm still waiting on this to get pulled. And this is the SD video file. So imagine if I was trying to write a video to it while watching a video. Like, the bandwidth just really isn't there. And so, you know, a lot of this is going to be in my review on this unit. But yeah, you really got to think about what you're expecting your NAS to do before you really get started on this project. That being said, if you have some old hard drives lying around, like, this is a really cheap NAS, that I will give it. So we'll look at this right now, and then when this is done, I'm actually going to do a couple more quick benchmarks on the system just so you can see those as well. I'm assuming this is going to play at some point. And granted, this is a really SD file, like, it, not high definition at all. Yeah. I'm gonna get copyright flagged for that one stupid thing. It's gonna be hilarious. Okay, so yeah, let's get back into Putty. Let's look at some benchmarks as soon as this is all done and said. 192.168.2.115. Lazy PC. Yes, I am. Waiting for this to stop copying. I'll throw it over here, that way we can see it. Boom. Check. Alright, now that that is done, I'm not going to go through a whole lot of benchmarking because it's obvious that the bottleneck here is always going to be that network speed as far as NAS purposes. But I just want to show you the speeds between the buses internally of the device. So I pulled up my list blocked devices again. We have SDA, which is a flash drive that's plugged into the Pi Zero itself. SDB, which is an mSATA drive that is on the expansion board of the OrangePi NAS, and then STC, which is a standard mechanical 5400 RPM 500 gigabyte drive that is connected to the expansion bus as well. So simple benchmark is going to be, I think you have to run this as sudo hd parm, and then we're going to flag this with a capital and a lowercase t, and then what disk we have. So let's start with our flash drive. I think, yeah, always make sure that you use your disk, not your partition or your mount point. So dev, we're going to do SDA first, which is our USB drive. Oops. So we see we got results of 314 and 13 in buffered megabytes per second on that. Let's do the same with SDB, which is the SSD connected to the mSATA interface that's on the expansion board. And you'll see that it's faster, but we're still, even in buffer disk reads, we're way exceeding what that network interface will allow us to do. And finally, our mechanical drive here, the SDC. And it's important to note that SDB and SDC are going through a USB interface just like SDA is. Difference really is in storage or bus speeds and whatnot. So you can see that the SSD has a little bit of performance boost over the mechanical hard drive. However, it is nothing like you would expect to see from an SSD in general, meaning that that SSD is capable of a lot more speed than this. The USB bus just doesn't do it justice, and I'll put that in my review as well. So there you go, that's a benchmark between the speeds of a USB flash drive, SSD on the mSATA part, and then a mechanical hard drive hooked up through the SATA port. Again, all of those exceed what you can expect to get from that network interface, and so this is a really tough call as far as NAS goes, and I'll talk about more in my review. So, whew, what a day, man. What a day. I gotta tell you, sometimes these things are not easy, and that's probably why there's not a whole lot of people that have done this yet. For that, feel free to like, subscribe, or anything else. If this has helped you, this is a lazy PC going to take a goddamn break.